Spur gears have straight teeth cut parallel to the rotational axis. Practice has shown that this design accommodates mostly rolling rather than sliding contact of the tooth surfaces. The involute curve is generated during gear machining processes using gear cutters with straight sides. Near the root of the tooth, however, the tool traces a trochoidal path, providing a heavier and stronger root section. Because of this geometry, contact between the teeth occurs mostly as rolling rather than sliding. Since less heat is produced by this rolling action, mechanical efficiency of spur gears is high, often up to 99%. Some sliding does occur, however, and because contact is simultaneously across the entire width of the meshing teeth, a continuous series of shocks is produced by the gear. These rapid shocks result in some objectionable operating noise and vibration. Moreover, tooth wear results from shock loads at high speeds. Noise and wear can be minimized with proper lubrication. Spur gears are the least expensive to manufacture and the most commonly used, especially for drives with parallel shafts. The three main classes of spur gears are external tooth, internal tooth, and rack and pinion. External tooth gears, the simplest arrangement of spur gears, is a single pair of gears called a single reduction stage, where output rotation is in a direction opposite that of the input. In other words, one is clockwise while the other is counterclockwise. Higher net reduction is produced with multiple stages in which the driven gear is rigidly connected to a third gear. Internal gears, as the name implies, teeth are cut on the inside surface of a cylindrical ring, inside of which are mounted a single external tooth spur gear or set of external tooth spur gears, typically consisting of 3 or 4 larger spur gears usually surrounding a smaller central pinion. 3. Rack and pinion gears. The rack and pinion is useful in converting rotary motion to linear and vice versa. Rotation of the pinion produces linear travel of the rack. The rack and pinion is used extensively in machine tools, lift trucks, power shovels, and other heavy machinery where rotary motion of the pinion drives the straight line action of a reciprocating part.